Humboldt, Craig, thank you very much. I always really appreciate being part of USAW for the last several years now, and really enjoy being here. And I really want to stress something that Mark said earlier in his presentation. If we have an early season snowpack, where that snowpack exists as we head into months of November and December, it's not a matter of if it's going to facet. It's when it's going to facet, how it's going to facet within the snowpack. And it's just anticipating that. And that's something that we should all keep in the back of our minds as we head in to the later months here over the next few months. So I wanted to start by looking back at, so we call it a banner October, right? And we'll look at that in more depth. But we've had early season snow across much of all the western mountains have done pretty decently. And we're looking at a snowfall analysis of analyzed snowfall accumulation across the western states. And as the colors get warmer, that's the more snow accumulation. If we zoom in on Utah, if we start up north in those yellows and oranges, it's generally about 1 to 3 feet of snow in the Bear River Range, working south in the central Wasatch. We've seen places 4 to 6 feet. Heading east into the Uintas. Very similar up in the high Uintas, but a little bit less in the western Uintas, generally about 1 to 3 feet. Similar across the Wasatch Plateau and far southwestern Utah. So that's accumulated total snowfall beginning October 1. Now let's zoom in where we saw some of those hot spots, and I'm going to focus on the Alta CoOp site, which we've got a pretty long period of record of snowfall. And here we're looking at a time series of snowfall accumulation in the vertical axis, and on the horizontal axis we're looking at a period of years dating back to 1979 when our data record has been consistent. And here, if we look at that circle on the right, that's accumulated snowfall for this month of October in 2021, about 48 inches. And I have a horizontal line drawn there from the beginning of the century because there's only 1 year since the turn of the century in 2000 that we've seen more snow. And just a couple weeks ago, I was talking with Craig in the office, and it was like, this is mid-October when we were getting consistent snowfall. People were getting after it in the upper Cottonwoods, skiing what was described as late season POW with a shallow base, or mid-season POW with a shallow base, and we were talking like, when can you remember the last time that we had such a banner October up to that point? And it was October of 2004, and we're going to be looking at 2004 in a little bit here, and kind of comparing, even though you can't strictly compare individual years and glean a ton out of it, there are some takeaways that you can learn from at times. So now we're looking at snow analysis of snow water equivalent through the end of October, and where you see those blues, that's where we have analyzed snow water equivalent or a snowpack existing. So the first slide I showed, it was total accumulation analyzed snow. So over that whole period of the month of October, there was probably 4 to 6 feet of snow that fell in portions of central Wasatch. Well, now we're looking at snow water equivalent, which is the measure of water in that snowpack. But one thing that you might notice is that there was widespread snowfall across all the north, but as the month turned into November, you look up in the Bear River Range outside of Logan, there's very little snow left. You work down south through the Ogden area mountains, very similar. The places that are holding on to the snow, and this is what we need to track moving forward, is where does the snowpack exist now as we get further into the late fall and early winter season. And in general, it's focused in the central Wasatch and portions of the Uintas, and mostly above 9,000 feet in the north half of the aspect or so, not much on the south sides. But let's look back at 2004 on October 31 and look how much more aerial expansive the snowpack was at that time, measure of snow water equivalent. And the color bar did change a little bit. There was no way around that when I pulled this image. But in general, there was not only more snow water equivalent over a larger area, over more aspects, but there was more snow water equivalent in the snowpack, especially in central Wasatch and Uinta ranges. If we zoom in again to 2004, there's, I think, portions of the central Wasatch Snowbird Snoel, pushing about 14 inches of snow water equivalent, whereas this year we're more in the 6 to 8-ish range at the best. Again, in upper Little Cottonwood Canyon above 9,000 feet. But very little snow in the south aspects, south side of the compass. The snowpack exists. One of the knowns that we can look at now is where does this early season snowpack exist before we go any farther, thinking ahead in the future. So now we're going to look at the Snowbird Snoel, and again, the vertical axis is a accumulation of snow water equivalent over time, which is the horizontal axis, beginning at the beginning of the water year. And that purple line is the median for the period of record from 1991 to 2020, the median accumulation and peak of snow water equivalent at the Snotel at Snowbird, a little over 9,000 feet in elevation. And that blue line is this year's, thus far, snow water equivalent. You can see we jumped up really quickly beginning through mid-month, and we've kind of plateaued, and we've jumped back and forth where we accumulate a bit and then we lose a bit. Well, that's a factor of the weather. Once we stop getting consistent storm cycles coming through, we've had more periodic ones. It hasn't been strong high pressure where we just go high and dry and nothing's happening. We've been kind of riding this curve back and forth where we lose a bit and then we gain a bit. Again, this is one of our higher snowtel sites. So it's indicative of the second half of the month being quite mild, and that's where we lost a lot of that snow that we saw fall originally early in the month. Now let's look at October, or the 2004-2005 accumulated SWE, and that's the green line, and we can compare it to the blue line of this year and median. It was a banner year from beginning to end, with quite a few large jumps in between, but let's really just focus on the here and now of October and the near future, where I circled here in red. Snowfall didn't really start until mid-month, and then it just kept going, and actually surpassed our snow water equivalent this year. Is a much better October, especially during the second half of the month. And I like going back and reading, old UAC annual reports on the season, where it talks not only about the avalanches, but the weather as well. And a few things to take out here. Beginning on October 7th, it just kept snowing. There was 122 inches of snow over those 2 weeks, almost 15 inches of water. This year, mid-mountain Alta, I think, is in the upper 60s for snow. And again, we're sitting around 8 inches of snow water equivalent. Looking back at the records, the 2004 October shattered every other October. So what happened in November? Well, you see a flat line there. Essentially in November, high pressure built in, and we went from consistent snowfall to a lack of snowfall. And what happened then in 2004? Well, October came in like a lion, November came in like a lamb, and it stayed that way. Underneath the high pressure, there was a prolonged period of clear skies and cooler temperatures. So one of the things that we can start thinking about is how weather and snowpack go hand in hand moving forward. We're going to talk about the weather here in a minute. But one thing of note, it was a deep enough snowpack that when that high pressure built in, we weren't getting faceting at the ground snowpack interface down low in the snowpack. It was all at the surface. So banner October, people are getting after it and skiing it up, green light, not much in the way of hazard. Then November hits, the faceting starts happening on the surface. It's still, go time. You're skiing the week later. you're not necessarily seeing it. And then it started turning on in December. Between December 10th and 11th, there was 4 fatalities in 2 separate incidents, and 2 very near misses as well. So it went from being banner in a good way and kind of green light where there was enough snow to everything kind of the rug getting pulled out of your feet. So going back to this year, there aren't many observations, but I found this from Ted out in the North Slope of the Uintas. And there are some similarities here, not as much snow, but the existing snowpack, as Mark mentioned earlier, is quite strong. It's right side up. There's a lot of water weight to it. Very little in the way of faceting. Only the highest north-facing slopes might have some initial trends of faceting. But, you know, where you can ski, there's not much of a avalanche hazard per se. Is you know, more of a hazard associated with rocks and stumps and other things buried within and on top of the snowpack. So where am I going? I get this question a lot, and I kind of think in cartoons sometimes. And this is where I'm going to start trying to tie in the knowns that we know. We know where the snow is. We kind of know the strength of the snow, where we measure it, stability. But what's happening weather-wise in the future? How is that snowpack? How can we anticipate that snowpack changing in the near future where we have relatively high confidence? And I'm going to do a caveat here. I had to turn this presentation in last Friday, and I pulled some forecast graphics from last Friday, but I also felt confident enough to do that with what we're looking at here moving forward in the near future. So I'm going to have to explain this image. There's a ton going on here. I'm going to start by talking about ensemble models on a global scale. And you've all heard about forecasting models. There are 3 primary global ensemble systems. And what an ensemble is it starts with initialization, and it gives you a variety of results over time. And if those results are closer together in its outcome, it's a higher confidence forecast within that model. If there's a lot of spread between, say, a dry outlier or a warm outlier to a cold or a wet one, then there's more uncertainty in the forecast. In the lower right, what we're looking at, there's 3 primary global ensembles. The EPS, which is the European model, it's got 50 different members, 50 different solutions in what we're looking at here. The USA model is the GEFS, and Canadian model is the CMC. The GEFS has 30 members, and the CMC has 20. So if you put them all together, there's 100 different members, and they're all going off on a little bit of a different tangent. But that lower right image is the median, or the mean, of all its members. And the warm colors are indicative of 500 millibar heights, kind of mid-atmosphere, anomalously high anomaly. The warmer the color, the more anomalous it is. So the lower right is showing a mean of strong high pressure developing this weekend and lasting into early next week. And then those other 4 images are broken down in clusters of similarities, where in the top left, 20% of the grouping of ensemble members are giving a solution like that one. All the solutions, however, are showing high pressure building over the interior Mountain West this weekend, and we're expecting that to last into early next week. So what comes with high pressure? And we've talked about it. We get typically less cloud cover. We get cold, clear nights. Cold, clear nights, lack of cloud cover. We get a lot of radiational cooling through the snowpack, and a lot of vapor transport and faceting processes can happen quite quickly. So here, if we look at the 18 to 14 precipitation outlook from the Climate Prediction Center, shows a similar thing where the warm colors, the table is tilted towards drier than normal conditions as well, with above normal temperatures, but that's not indicative necessarily of temperatures, let's say on a north-facing slope that doesn't get much sunlight for the overnight hours where you get strong radiational cooling and the fastening process most likely. So I've got to talk about it quick. So we have knowns, we have anticipated knowns of what the weather is going to do and how the weather may change the snowpack. How is that going to affect things seasonally? Well, that's where it gets a lot trickier. But what's always in the media typically is the ENSO cycle, which is either La Nina or El Nino. And right now, it's not going to tell you much as far as seasonal outlook. For Utah, we're mid-latitude state, and we don't really have a strong signal either way in whether it's going to be a banner year or a bust. So real quick, just climatically how La Nina changes things. It's an upwelling of cool water off the coast along the coast of South America that then rides the easterly trade winds, creates cooler than normal sea surface temperatures, more active, wetter weather in Indonesia, switches the global jet stream where you typically get cooler than normal conditions, British Columbia, and wetter normal conditions into the Pacific Northwest and northern latitudes of the West Coast. How that happens, it's essentially a phase shift of the mean jet stream and how it might split around high pressure over the Central Pacific region where the southern branch of the jet undercuts high pressure and the polar jet rides up and over the high pressure and then descends down into the northwest, bringing cooler air. If we look at climatology for La Nina events dating back to the beginning of the period record, back into the late 40s, I believe, the warm colors are below normal precipitation, and the cool colors are above those greens. And if you look at individual years, and these are for moderate to strong events, you can pretty much find whatever you're looking for, especially in Utah. We have some above normal, we have some below normal. If we look at just snowtail climatology for areas across Utah, these cool colors, the blues, are hedging more towards above normal precipitation. But the big thing is the further north in latitude you go, the more above normal you typically are. The further south in latitude where you get in those pinks, the more below average you are. And we're kind of right there in the middle somewhere. So I wanted to do kind of a poor man's climatology and kind of a poor man's ensemble spread of snowtail years dating back to 1991 for a few sites in across the state of Utah. Starting in the north, so in the Bear River Range at Tony Grove, we're looking at all the La Nina years, all 12 of them dating back to 1991. And the median is here in the purple, where the peak SWE is about 35.6 inches. But if you look at the spread, so there's a ton of spread. You have a lot of years below the median, a lot of years above, and that spread's actually about 40 inches of snow water equivalent with a low of 26 and a high of 66. But I want to kind of look at years above and below normal, and where near normal is within 10% of that median SWE. And here, more often than not, 9 out of 12 years, Tony Grove had near above normal snow water equivalent with only 3 below. If we work further south in latitude, again, you'll see significant spread. Apologies, I've never been a good speller, so misspelled Ben Lohman here. So again, significant spread. Banner years near 60 inches of SWE, and bust years all the way down to about 19 inches of SWE. But near above normal, 8 out of 12 years. Working further south into Snowbird, very similar, near above normal, 7 years, years below 5. But we're starting to see more of a switch from the table being tipped further north in latitude to the table being tipped further south in latitude. If we work down into southern Wasatch Plateau, here at Farnsworth Lake, it's more tipped to being, closer to normal, less spread, or below normal, and even more so down in Midway Valley in the southwestern mountains. The official seasonal outlook and seasonal outlooks, the one thing that they don't key in at all is how it's going to play out. This is looking at 3 months and the greatest likelihood of that outcome over that 3-month period. If we're looking at temperature, the warm colors are where the table's tipped slightly to warmer above normal temperatures, which you see across all the state of Utah. Cool colors below. The whites are equal chances where there's no strong signal one way or another to tip that table. So you can see here we're still in that dividing line between below normal favored and above. So working backwards, just some quick takeaways. Any one climate signal, it doesn't guarantee a banner or bust season locally. The tables tip more for warmer than normal temperatures across the Intermountain West this year, especially from say, Utah south across desert southwest. The tables also tip to above normal precipitation, favoring the further north in latitude you go across the western U.S. And the big takeaway is seasonal outlooks. They don't handle shorter duration, smaller scale pattern shifts. It doesn't tell you anything about prolonged dry periods or storm cycles, especially the timing of those. So further north you are in Utah, you're more likely to see greater precipitation than further south in latitude across the state. It doesn't necessarily tell you how much more, if it's going to be normal or above or below, but typically you see more further north. You can't compare individual seasons directly, but there are some things that you can learn from the past. Here we just talked about 2004 a little bit. Watch that ridge, where it develops, because the ridge this time of year, that change in the snowpack is going to be highly tied to that ridge development. And right now, we know where the deepest snowpack it is, high north across the Wasatch and higher Uinta areas. How is the anticipated weather in the future going to start interacting and changing that snowpack? That's all I have. Take some questions.
Well, most excellent. Thanks, Mr. Merrill. And, kind of reflecting on that 04-05 season, there's been a lot of correlation with this year. Remember in 04-05, we've got the 4 fatalities that right off the bat in December. Got a dry spell, and then, January comes roaring back. We add up 4 more fatalities during that time span, historic avalanches. But remember, it's a deep snowpack, much like Mark was saying, much like Glen was saying. Eventually, it did turn the corner. Things consolidated, things healed. It was a really epic corn season. So this is great to bring up some historical reference, and we always appreciate Glen coming up and sharing his College of Weather Forecasting knowledge with us. We're going to kick off some questions here, Glen. And so what type of weather patterns have you noticed for early season snow during your time here in Utah? And have you noticed any changing patterns?
Really, you can't, there is no strong signal. Every year is different, and every year is going to be different. If we look back across the period of record across the Southwest, and you look at precipitation and you look at temperature dating all the way back to the 1850s, across the Southwest, including Utah, we see precipitation, strong variability. We go through periods of wet conditions, and we go through periods of dry, and that can be multi-decadal. It can last 1 or 2 decades at a time. Very dry period in the 60s and the 70s, very wet period in the 80s, and this is all weather variability. If we want to talk about change, you start looking more at the climate side of things, and if we look at temperatures, it's much different when we focus on temperatures, where before the 1970s or so, had a very similar signal to the precipitation. Warm periods, dry periods, there wasn't much takeaway, there wasn't much signal. But after the 1970s, there's been a clear trend of a warming of temperatures across the Southwest. This is global warming that you hear about, where each decade we're increasing temperatures by about 0.7 of a degree, and that's continuing now. So if we go back to the original question, anything I've noticed, well, no, outside of the frequency of higher snow levels, more often than not, in the Wasatch, a trend of the snowpack beginning to melt out earlier than it used to, and that's a big water supply issue for water managers across the state. But no strong signal as to when we're going to have a good October and when we're not.
Awesome. Great question. Great answers. And hey, Glenn, these weather models that you're talking about, which ones do you find either favor or tend to be kind of that ground truth for the Wasatch? Which ones do you steer more towards?
Well, the name of the game, especially now, it's not picking any one model. That's more of the past. We had fewer models to go off of. Now we've got so many models of varying resolutions, computational skills. What it is it's lumping all these models together to create more of a probabilistic outcome. And there are some models that perform better than the others. The primary go-to globally is the European model. But it's really taking all that information in and digesting it and trying to come out with the best solution, and not only the best solution being the median or mean, but your confidence level and the amount of spread in the outcomes of these models. Because if they're all saying more of a general same thing, you can have a higher confidence versus if they're giving you a lot of variation.
Fantastic. How about one more question for you, Glenn, since we got you here tonight. If La Nina and El Nino don't provide great estimates for Utah, what are the large-scale weather patterns that might predict banner years in upcoming winters for Utah?
You know, with Utah being in the mid-latitudes of the West, it's really hard. There's studies, just today I was talking with John Meyer at Utah State, who's a climatologist up there, and they're looking at the certain other oscillations. They've been looking at other oscillations like the Pacific Decadal and how those play, and really being in the mid latitudes of the West. You can lean a little bit here and there, but there's nothing that really tells you. I mean, seasonal forecasting is extremely challenging. Just think about how challenging forecasting within a week's time is in detail, let alone as you go further out in time.